This lesson is about rates of change. So far we've been using differentiation to find the gradient of a point on a curve. Well, the gradient is the rate of change of one variable, so y, with respect to another, x. And that is why you show it as dy over dx. It is a rate of change of y with respect to x. So try not to think that it's the rate of change of the variable on the numerator with respect to the variable on the denominator. Now, given that h equals to 1 over 5t squared, find the rate of change of h with respect to t. So you want to find dh over dt. Okay? When t is equal to 2. So firstly, we're going to just differentiate this thing right here, where we will get 2 over 5t. And then what we can do is put t equals 2, and we get the answer to be 4 over 5. Next example, variable v and t are connected by this equation right here. Find the rate of change of v with respect to t. So you want to find the rate of change of v with respect to t. That means you're going to differentiate this equation right here with respect to t, and you will get 4t minus 3. And you want to find that when t is equal to 4. So we will just get 4 times 4 minus 3, which is going to be 16 minus 3, which is going to be 13. When two variables x and y both vary with a third variable t, we can connect those three variables using chain rule. We saw a slight example of this under the u substitution part. We will also sometimes use this formula right here, where dy over dx is just going to be the reciprocal of dx over dy. So 1 over dx over dy. This is how you find the reciprocal, by the way. So if you want to find the reciprocal of a, that is going to be 1 over a. So 1 over dx over dy. Therefore, the reciprocal of dx over dy is going to be dy over dx. This example shows exactly that. A point with coordinates xy moves along the curve y equals to x plus root 2x plus 3 in such a way that the rate of increase of x has a constant value 0.06 units per second. Per second means you are dividing by time. Therefore, the rate of increase of x, dx per unit time, dt, will equal to 0.06. Find the rate of increase of y at the instant when x equals to 3. So we want to find the rate of increase of y, so we want to get dy over dt when x is equal to 3. So with this right here, we can show a formula where dy over dt is going to just equal to dy over dx times dx over dt, where dx is cancelled out to give you dy over dt. So we have this right here, which is 0.06. We will need our dy over dx, which is just the derivative of y with respect to x, which you get from this right here. So this equation can be written as y equals to x plus 2x plus 3 power half. And differentiating this will give us 1 plus 2, so the derivative of whatever is inside the bracket, 2 times the power half times the bracket 2x plus 3 power minus 1. So 1 over 2 negative. This will just be 1 plus 1 over root of 2x plus 3. That is our dy over dx. When x is equal to 3, that is going to be 1 plus 1 over the square root of 2 times 3, which is 6, plus 3, which is 9, which gives us 1 plus 1 over 3, which just gives us 4 over 3. So the value of my dy over dx when x equals to 3 is 4 over 3. Then I want to multiply it by 0.06, because that's our dx over dt, to get our dy over dt. And multiplying these, you can cancel these out. You get 0.02 at the top, and this will just give us 0.08 as our answer for dy over dt. This 0.08 is a positive value, which means our y coordinate is increasing. Next, oil is leaking from a pipeline under the sea, and a circular patch is formed on the surface of the sea. The radius of that patch increases at a rate of 2 meters per hour. So the radius is increasing, therefore dr over dt, because you're looking at time per hour, and dr over dt is equal to 2, where obviously the t is in hours, right? Find the rate at which the area is increasing when the radius of the patch is 25 meters. So you want to find dA, the area is increasing, obviously the rate of it, so over dt, and you want to find that when r is equal to 25. So for that we need to introduce a new formula. Obviously they haven't given us any formula like they did above, but you should be able to figure out what formula they're asking for, because they are relating area and your radius, and it's a circular patch. This will give us that area equals to pi r squared. And obviously when these two are there, to find dA over dt, you will need to do dA over dr multiplied by dr over dt, where r's will cancel out and you'll be left with dA over dt. This right here is the differentiation of area with respect to radius. So we're going to differentiate this, and we will get that dA over dr is equal to 2 pi r. Putting in our value of r, which is 25, this will give us that dA over dr at when r is equal to 25 is just going to be 2 times pi times 25, which is just 50 pi. Therefore, dA over dt will equal to 50 pi multiplied by dr over dt, which we got was 2. This is going to give us 100 pi. Therefore, the rate at which the area is increasing when the radius of the patch is already 25 meters is 100 pi meter squared per hour. That's the rate at which the area is going to be increasing, dA over dt. Next example, a solid sphere has radius r centimeters, surface area a centimeters, and volume v centimeter cube. Firstly, let's write the solid sphere's surface area and volume formula. So the surface area is equal to 4 pi r squared, and the volume formula is equal to 4 over 3 pi r cubed. The radius is increasing at a rate of 1 over 5 pi centimeter per second. Therefore, dr over dt, the rate at which the radius is increasing, is equal to 1 over 5 pi. Now find the rate of increase of the surface area when r equals 3. For that we need to find our dA over dt, and in order to get that we will obviously need the middle term, which is dA over dr. And this you will get by differentiating your area formula, from which you will get 8 pi r. Putting in our value of r, which is 3, we get back 24 pi. Therefore, dA over dt, which is equal to dA over dr multiplied by dr over dt, this will be dA over dr is just 24 pi, and dr over dt is 1 over 5 pi. This will give us the answer to be 24 over 5. That is going to be our rate of increase of surface area when our radius is 3. Next, you're told to find the rate of increase of the volume when the radius is 5. So same thing, we want to find dV over dt this time, and for that we will need our dV over dr. That in this case is just going to be 4 pi r squared, and you want to find it when r equals 5. Therefore 4 times pi times 5 squared, which is 25, which will give us 100 pi. Then to find our dV over dt, we're going to take our dV over dr multiplied by our dr over dt. That will give us 100 pi, which is dV over dr when r equals 5, multiplied by dr over dt, which is a constant 1 over 5 pi. And this will give us 20 pi as our answer. So this is the rate of increase of volume when the radius was 5. Water is poured into the conical container shown at a rate of 2 pi centimeter cube per second. That means the volume is changing at the rate of 2 pi centimeter cube per second. Therefore, dV over dt is equal to 2 pi. After t seconds, the volume of water in the container v centimeter cubed is given by v equals to 1 over 12 pi h cubed, where h is the height of the water in the container. Find the rate of change of h when h equals to 5. So we want to find what dh over dt is when obviously h is equal to 5. So over here we have two variables, our volume and our h, right? So we will have a third term which is going to be dv over dh, where you differentiate the volume formula, right? However, you want your dh over dt, so dh over dt will equal to dh over dv, because you want this in the numerator and you want to get rid of the dv, so you'll multiply it by a dv so that they cancel out, and you want a dt at the bottom, so we're going to add this right here. What this will do is it will cancel out the dv's and we're left with dh over dt. So dh over dv is just a reciprocal of this, so once we find dv over dh, we can just reciprocate that to find dh over dv. dv over dt on the other hand is just going to be 2 pi. So in order to find dh over dv, we're just going to find dv over dh, which comes as a result of differentiating this equation right here, where we're going to get 1 over 4 pi h squared. And when h is equal to 5, we just have 25 pi over 4. That's dv over dh. We needed dh over dv, therefore we are going to reciprocate this right here, which will give us 4 over 25 pi. So dh over dt, which is what we want to find, the rate of change of h, when h is equal to 5, dh over dv is going to be 4 over 25 pi, and that you'll multiply by 2 pi right here. The pi's and pi's will cancel out. We end up getting 8 over 25. And that is going to be the rate of change of the height when the height is 5. The second part, given that the container has a radius of 10 centimeters and a height of 20 centimeters, find the rate of change of the height when the container is half full, and give your answer correct to 3 significant figures. So for this, we need to find the volume when the container is half full. This right here is a cone, and the volume of a cone is equal to 1 over 3 pi r square h. If you put in our values, 1 over 3 times pi times r, the radius, which is 10, 10 squared is just going to be 100, times h, which is 20, we're going to get 2000 pi over 3. That's the volume of the entire cone. If the container is half full, that means this is just going to be divided by 2, and our volume is going to be 1000 pi over 3. Now we want to find the rate of change of h, which is dh over dt, when the container is half full, so when our volume is 1000 pi over 3. But remember, we will need to find the h that corresponds to this value right here. That's the volume formula for the volume of the water in the container after t seconds. We want the volume of water in the container to be 1000 pi over 3. Therefore, we can just substitute that 1000 pi over 3 is equal to 1 over 12 pi h cubed. This is going to give us 4000 is equal to h cubed, where you can cube root both sides, and you will get that h is equal to 15.874. So that is the height at which we want the rate of change of the h. And for that, again, the other information we have is that dv over dt is equal to 2 pi. And our dv over dh formula is just going to be 1 over 4 pi h squared. So to find dh over dt, we want dh to be in the numerator, so dh over dv times dv over dt. dh over dv is just the reciprocal of dv over dh. We can find the value of this when h is 15.874. So 1 over 4 pi times 15.874 squared. This is going to be 197.9. Therefore, that's dv over dh. dh over dv is going to be the reciprocal of that, so 1 over 197.9. And you're going to multiply that by dv over dt, which is 2 pi. and that is going to give us 2 pi over 197.9. That's going to be the value of dH over dt. Into three significant figures, that's going to be 0.0317 centimeters per second. That's going to be the rate of change of H when the volume is 1000 pi over 3, and as a result the H is 15.874. The final example, a container is made in the shape of a hollow inverted right circular cone. The height of the container is 24 centimeters and the radius is 16 centimeters. Water is flowing into the container. When the height of the water is 8 centimeters, the surface of the water has radius r, and the volume of the water is v centimeter cube. We need to show that v is equal to 4 pi h cubed over 27. So we want to find the volume of the water, which is going to be given by 1 over 3 pi r square h, but we want it in terms of h. Therefore, we need to have a different way of representing r. Okay? The way we're going to get this is using similarity, where we can introduce two triangles. One is a triangle of the water volume, and the other one is a triangle of the cone volume, right? These two triangles are going to be similar. Okay, so this one right here, the big one, and the smaller one. These are similar triangles, where this height is h, this is r, this is 16, and this is 24. Because they're similar, and they're similar, how do we know? Because they share this edge and they both have a right angle. Therefore, this angle is also going to be the same. Then these lengths can be written as a ratio of each other. Therefore, r over 16 is going to equal to h over 24. Making r the subject, we get that r is equal to 16h over 24, which is just 2 over 3h. So r is equal to 2 over 3h. What we can do is substitute this back into the volume formula. That gives us 1 over 3 pi times 2 over 3h squared times h. This gives us 1 over 3 pi times 4 over 9h times h, which is going to be 4 pi h cubed over 27. That's going to be our volume in terms of height alone. Water flows into the container at a rate of 8 centimeter cube per second. Therefore, our dV over dt, the rate of volume, the rate of change of volume is 8 centimeter cube per second. So 8. We need to find in terms of pi the rate of change of h, which is going to be shown as dH over dt, rate of change of h. And we want to find that when h is equal to 12. Combining these two variables, we get that v is equal to 4 pi h cubed over 27 from part A. And in order to find dv over dh, which we will need as the third term, this is going to be 4 pi h squared over 9. When h is equal to 12, we have it to be 4 pi times 144 over 9, which is just going to give us 64 pi. That's going to be the value of our dv over dh when h is equal to 12. Now what's left is to find dh over dt, which we will get by doing dh over dv multiplied by dv over dt. So dh over dv is just the reciprocal of dv over dh. Therefore, we're going to keep 1 over 64 pi. Then dv over dt is just 8. Multiplying these two, we will get 1 over 8 pi. And that is going to be the rate of change of h, dh over dt, when h is equal to 12. That's going to be our rate of change.